Today we create 2.5 quintillion bytes of data every single day. And that number will continue to grow with the number of connected devices. But what's really important about the fact that everyone's talking about data is just that. We're talking. Using our voices is and always will be the most human form of communication. It helps us make connections with each other and influence the world around us, regardless of where we are or what device we're using. Right now, Nokia's leading network solutions are enhancing how we talk to one another and to the things around us by delivering voice calling that lets your voice come through on any device, using your own personal number, regardless of the application. That means you can start a conversation on your tablet and continue on your phone, moving seamlessly between 2G, 3G, 4G, Wi-Fi, and ultimately 5G. And it means you can continue to talk while you're using some of those 2.5 quintillion bytes of data, even at 5G speeds. Nokia VoLTE, or Voice over LTE, is the core for human communications, delivering an amazing voice and data experience. It's helping operators provide the highest quality connections with HD and Ultra HD voice calling and the most innovative service enhancements. It's putting faces to all those voices out there with high quality, real-time video calling that's just as clear and easy as voice calling. And it's helping to create a world where you can control more and more things with your voice. Right now, Nokia Networks is continuing to do what it's always done best, using technology to help people do the most human of things, to connect to one another and to a big and growing world of connected devices. And it's giving people all over something to talk about.
Hi, my name is Maneesh. Let's start the session. We are going to discuss about the topic called IMS, IP Multimedia Subsystem. Before we discuss about IP Multimedia Subsystem, let's talk about in general. So we all use mobile phone, right? We all use mobile phone to make a voice call, to make a video call, or someone use to browse internet, to watch videos on the YouTube, upload photos on the Facebook, download photos from the Facebook, etc. Right? Of course, we all use mobile phone for the multiple purpose, right? So think about, we have some kind of applications like Skype, and what are the other kinds of application we use to make a video call? Yeah, Zoom is one of the application we use nowadays. Skype we use Google account to make a video call, right? So these all are the different kinds of applications we use in order to make a video call. So what are these technology? These technologies are called over the top, OTT, over the top technology, right? There are some drawbacks in terms of over the top technology. The drawback is nothing but it's not secure. We are using internet in order to make a video call using these kind of applications. So how do you make a video call using a Skype? Yeah, let's discuss based on the Skype video call, right? We have a username. Say example, my username is Maneesh and my password is Maneesh@123. I logged into Skype applications using this username Maneesh and password Maneesh@123, and I am able to make a video call to my friends or my neighbors or my family members, right? Why did I say over the top technology are not secure? The reason is, if I discuss or if I tell my password, that is Maneesh and Maneesh@123, to my friends or to my neighbors, or of course to you people are able to log into my Skype account and able to make a video call. right? So the authentication is taken care by, or I would say, uh, the authentication is in terms of username and password, right? In the over the top technology. So if I share my username password to any one of you, you will be able to access my Skype account, right? And you can make a video call. So it's not secure in terms of security. Yeah. So this is one part of the internet. Of course, we can use this kind of application to make a video call as well as a voice call, right? But these are not secure. This is one part of the internet. Let's talk about the other side of technology, right? So we use mobile phone to make a voice call, and we use mobile phone to make a data call. So when I say data call, it's nothing but browsing something on the internet, uploading photos to the Facebook. These all are called data calls, right? Let's take an example. I'm watching videos, or I'm watching a movies on a YouTube channel. I'm watching a movie on a YouTube channel. I started to watch. The moment I watching the movies on the YouTube channel, I got a call from my neighbor, right? When I got a call from my neighbor, I observed a change on my mobile phone, the home screen. Initially, when I watch movies, initially the signal level was 4G. When I got a call, my signal level from 4G fall back to the legacy network, 3G network. So what it means for you? It means when you are on a data call, let's say like this, you have connected to 4G network and you are making a data call. When you are on a data call, which means browsing internet, you got a call, you got a voice call, your signal from 4G network will fall back to 3G. So this is called circuit switch fallback, CSFP, circuit switch fallback, right? So it's a good technology, but the drawback is when you are on a 4G network and you got a voice call, why should you fall back to 3G network? Why can't you access, or why can't you make voice call when you are on a 4G network? So there becomes the applications of IMS. So the IP Multimedia Subsystem, that is IMS, which is used to make a voice call when you are on a 4G network. Suppose you have this IMS technology on your, you have the IMS technology added to the 4G network, then you don't have to fall back to 3G in order to make a voice call. You be there on the 4G network, you be there on your data, you be there, you continue to watch the movies on the YouTube, still you will be able to make a voice call when you are 4G, given that you have this IP multimedia subsystem added to the existing technology, right? So this is one of the main advantage of IMS, which is called IP multimedia subsystem. The technology is called voice over LTE. So you are on a LTE network, which means you are browsing something on the internet, you got a call, you don't have to fall back, you be there on the LTE, still you will be able to continue to the voice network. So that is called voice over LTE. Yeah. Let's start the session. These are the different slides which I'm going to explain. We will have an introduction, and we have the elements of IMS, we have IMS architecture, we have IMS registrations, we have the different interfaces connected to the different nodes of IMS architecture, and we have an example call flow scenarios, right? Let's talk about the different elements of IMS. We have something called CSF, which is called call session control function, and we have HSS, home subscriber server. We have PCRF, policy charge ruling function, and we have AS, which is called application system. So we will cover each elements in details in the coming slides. So let's talk about CSF. So what is CSF? The call session control function is the main SIP-based node in IMS. It handles the SIP signaling in the IMS. There are three types of the, I would say like this, there are three different types of CSF elements. Let's say like this, I divided the CSF into the functionality of CSF into three categories, right? So I divided CSF into PCSF, ICSF, and SCSF. The PCSF stands for proxy CSF, ICSF stands for interrogating CSF, and SCSF stands for serving CSF. As I said, the proxy CSF is the first type in the CSF. As the name suggested, the functional element behaves as a proxy server between the IMS terminal and the network. So what does it mean? The proxy CSF, it's the first point of contact from a UE point of view towards the IMS network, which means when I say UE, it's nothing but the user endpoint, nothing but your hand phone, your mobile phone. When your mobile phone try to reach IMS network, the PCSF, the proxy CSF is your first point of contact. Moreover, PCSF validates and forward the SIP request and responses towards the IMS terminal or towards the IMS network. Since this is the first point of contact from a UE point of view towards the IMS network, it brings more security into the CSF node. So basically the proxy CSF, the PCSF is the first point of contact from a UE point of view towards the IMS network. Since this is the first point of contact, it brings more security towards the CSF node. So what is the second node? The second node is ICSF, which is called interrogating CSF. The ICSF act as proxy for the CSF entities within the network. In addition, the ICSF has an interface towards the SLF and the HSS. So we are going to explain the interface between the ICSF and HSS in the coming slide. So it takes a major role when it talks to HSS to get some kind of information, right? The interface between ICSF and HSS is based on a diameter protocol. The other functionality of ICSF is the ICSF retrieves user location information and routes the SIP request to the appropriate node. And which is the third element in the CSF? The third element in the CSF is SCSF, which is called serving call session control function. So we generally say the CPU is the brain of the computer, right? So similarly, the SCSF is the brain of CSF. It is the main signaling node in the CSF. Which is the main signaling node in the CSF? The serving call session control function. The serving call session control function is a SIP server with SIP registrar functionality. The SCSF authenticates user and registers to the IMS services. The SCSF also have an interface towards HSS, which is nothing but diameter protocol. So why do we need an interface between SCSF and HSS? The reason is that the HSS will contain the information about the subscriber. I'm going to explain those information in the coming slide. So in order to download the subscriber information from HSS towards SCSF, we have an interface which is a diameter protocol. So we talks about the different elements of CSF, which is nothing but PCSF, ICSF, and SCSF, which is the next element in the IMS. HSS, the home subscriber server. The home subscriber server is the main user subscription information database. It is the evolution of the home location register, which is called HLR. The HSS plays a major role for the authentication of the subscriber. So basically what HSS contain, alright? So we say HSS contains subscriber information. So what are these information? Say example, I'll give a general example. I'm going to buy a new SIM card from a shop. Let's say a SIM card from Vodafone. So I went to a shop. I told the shopkeeper I need a SIM card. He has given a SIM card and he has given an application form. He wrote something on the application form. He written the address, my name, the MSISDN, which is the 10-digit number. Then he written a 15-digit number, which is called IMSI. So he has written all this information on the application form. So basically, the subscriber information is nothing but this information plus the services what we are going to get it from the service provider. The home subscriber server, it's nothing but it's a database which contain the details of the subscriber. Then we have something called PCRF. So what is PCRF? The PCRF is nothing but the policy charging rule function. The policy charging rule function is responsible for making policies and decision management in the IMS and the LTE core networks. The PCRF has many duties such as controlling the network resources, managing the bandwidth to satisfy the quality of services. In addition, PCRF provides the charging functionality. So suppose you are a postpaid customer and you receive the monthly bills on, let's say, end of every month. So who helps to create the bills on every month? So PCRF, the policy charging rule function, plays a major role, or it talks to the billing server in order to make the charging functionality. Then I also touch up that the PCRF control the network resources and managing the bandwidth to satisfy the quality of services. I'll give an example. Let's say we have let's say there is a cricket match in any of the stadium. Let's say in Chinnaswamy Stadium we have a cricket match, and most of the users watching the cricket match they are on mobile phone, and these mobile phones are trying to attach to the nearby base station which is near to the stadium, right? Say example, there is a user called A. So he has taken a service from a service provider, let's say Vodafone, and he is paying, say example, 2000 rupees per month. And he told them that I need, since I am paying 2000 rupees, I need a good quality of services. What it means? Suppose the number of users connected to the nearby base station increases, there are less chances of the signal strength, which means the signal strength will reduce, right? Even though you have a very low signal strength, for this particular user, user A will get a dedicated bandwidth to connect to the internet, so which is provided by the PCRF, because he is a prime customer from the service provider point of view. The PCRF policy charging rule function provides that functionality to this particular user called user A, because he is paying a higher charge to the service provider. So even though the signal strength is very less for all other users, this particular user will have a high signal strength because he has a dedicated bandwidth, a dedicated pipe towards the core network. So this is the functionality of PCRF. So next we have AS, which is called application server. So let's talk about the functionality of application server. So application server provides call diverting, call forwarding, call waitings, etc. So what are these functionalities? Let's say example, there is a student called student A. So he is attending one of the class from a professors, and he don't want to miss the lecture class from the professor, and he's sure that he is going to get a call from his mom, so he don't want to miss the call. So the scenario is the student A is attending a class and is going to get a call from his mom, and he don't want to miss the call and he don't want to miss the class. So what he do? So he has a functionality on his mobile. So he did call diverting to his friend who standing outside the classroom. So when he got a call on his mobile, since he does the call diverting, the call has been diverted from his mobile phone to his friend, so that the friend can attend the call and he can still be on the lecture class. Yeah, so these are the functions of application servers. So the application server is basically for call forwarding, call diverting, call waiting, etc. So we already discussed about CSF, the call session control function. We discussed about HSS, home subscriber server. We discussed about PCRF, policy charging rule function. Discussed about AS, application server. So we discussed about the three different elements of CSF. Those are PCSF, ICSF, and SCSF. The architecture of IMS. So we already discussed about the different fundamental elements of IP Multimedia Subsystem. Those are PCSF, ICSF, SCSF, then we have HSS, then we have PCRF, then we have application server. So as you can see here on the architecture, in addition to the PI and SCSF, we have one more element which is called BGCF, which is nothing but the border gateway, or I would say breakout gateway control function. So the BGCF is nothing but the breakout gateway control function. So what is basically the functionality of the breakout gateway control function? The breakout gateway control function basically used to break out the call. From the name it says that it's used to break out the call from an IMS network to a circuit switch network. So the breakout gateway control function is only used in session that are initiated by an IMS terminal and addressed to a user in a circuit switch network. So what it basically means, when an IMS user tries to call to a circuit switch network, which is your legacy network, or to a PSTN, which is nothing but your landline, the breakout gateway control function uses its functionality to break out the call from IMS to the legacy network. If the telephone number belongs to the same network, then this element route the SIP session to a proper circuit switch gateway. On the other hand, if the telephone number belongs to another network, then this element will route the SIP session to another BGCF. So basically what it means, say example, a user A, he is into a Vodafone IMS network, and the user A is trying to make a call to the user B. The user B is also from an IMS subscriber from the Vodafone network, which means the both telephone number are belongs to the same network. The network is from Vodafone. Then this element, the breakout gateway control function, will route the SIP session to a proper BGCF, the breakout gateway control function. So I'm going to explain the functionality of BGCF when I talks about the call flow session scenarios. Then we have something called the MGCF, which is nothing but media gateway control function. The media gateway control function is the IMS gateway to a PSTN and a circuit switch users. It converts the SIP to either an ISDN user part, which is nothing but ISUP, or BICC, bearer independent call control. In addition to the call control protocol conversion, the media gateway control function controls resources in the IMS media gateway. So basically what you should understand here, we have something called MGCF media gateway control function, and we have MGW media gateway. So these elements uses, or it controls the resources in the IMS gateway, and it uses or it functions when it talks to, when the IMS network talks to the legacy network, right? So we talks about the breakout gateway control function, we talk about MGCF, and we talk about MGW. Similarly, we have BGW, border gateway, and we have MRFP. So basically the bottom line is the gateway servers are used to control the resources in the core network. Yeah. So let's talk about the IMS call flow scenarios. So let's talk about the registrations. Then we go to intra IMS call. Then we go to IMS to a PSTN call. In order to make a successful registration to an IMS network, the mobile phone or the UE should authenticate to IMS network. In order to register to the IMS network, the UE should authenticate to IMS network. That's a basic thing. In order to authenticate the UE to the IMS network, the UE should register, the UE should send a SIP register message. So I'm going to explain the SIP register message here. So you have the UE, the user endpoint or your mobile phone. And as I discussed, the PCSF, which is nothing but the proxy CSF, is the first point of contact from a UE point of view towards the IMS network, right? So we are going to discuss about IMS registration. The IMS registration, in order to do IMS registration, the UE should authenticate to network. So let's talk about the authentication process of the UE towards the IMS network. So as you can see here, the UE send a register message called SIP register, and the SIP register received by PCSF. As soon as the SIP register message received by PCSF, proxy CSF, the proxy CSF has to send this register message to the next element of IMS or the next element of CSF, which is nothing but ICSF, interrogating call session control function. But the challenge here is, how does the PCSF know I should send the register message to which ICSF, right? Then we have an element called DNS, the domain name server or domain name service, which basically convert the name to an IP address or vice versa, right? So when you type say example google.com on your browser, so basically it converts the name to an IP address and it try to talks to the Google server which is there somewhere, right? So the DNS, the domain name server, basically it's used to convert the name to an IP address. So similarly, as soon as the register message received by PCSF, the proxy CSF, it talks to DNS in order to get the IP address of ICSF, right? So the SIP register message received by PCSF, it's sent to DNS. There we go, the DNS. The DNS send back the IP information of ICSF, right? So as soon as the DNS receive the information from the DNS, the PCSF send this register message to ICSF. So we have interrogating CSF here. So the interrogating CSF has an interface towards HSS, the home subscriber server. So now the register message is with the second element of CSF, which is nothing but ICSF. So who is the third element? The third element of CSF is nothing but the SCSF, which is nothing but the serving call session control function. So as soon as the register message received by ICSF, it's sent to HSS in order to get the information about the SCSF. Okay. So let's say the ICSF received the information of SCSF, the serving call session control function. Then what it does, the ICSF send the SIP register message to SCSF. Now SCSF again has an interface towards HSS in order to authenticate the subscriber. So what SCSF does, as soon as the SCSF receive the SIP register message from the ICSF, SCSF talks to HSS and asks, say like this, I got a SIP register message from I, and I'm going to check in your database whether this is a particular or this is an authenticated user. So basically what happens, the SCSF send a query, the authentication info and the user profile to HSS. As soon as the HSS receive this information, HSS check in his database about this particular subscriber, and HSS share some kind of random keys and authentication tokens to the SCSF. So what SCSF does, as soon as the SCSF receives the authentication key and the token numbers from HSS, SCSF forward this message to I forward this message to PCSF, and PCSF forward this message to UE. So basically the authentication is taken care now. So suppose, let's say example, the UE has authenticated whatever the token, whatever the authentication key and the token sent by the HSS, and whatever the authentication key and token the UE has, once it matches, we can say the UE is authenticated to IMS network. Say example, the UE is authenticated to IMS network. Now we have the IMS registration. We'll talk about this task also. So we discussed about application server, right? The AS, which is used to do a call diverting, call forwarding, call waiting functionality, etc. So the application server which used in IMS is nothing but as telephony application server. Suppose the user needs the task functionality, the user has to authenticate to telephony application server, means it has to register to task. So basically the SCSF send the register message to task. Task also has an interface towards HSS in order to authenticate the user. So at this point, say example, the user is authenticated, and once the user is authenticated, the UE will send a SIP register message towards the IMS network in order to register. So again the flow is saying the UE will send a SIP register message to PCSF, PCSF send the register message to ICSF, ICSF query to HSS, HSS reply back SCSF information. As soon as ICSF receive this information, ICSF forward this message to SCSF. Now SCSF talks to HSS and it tries to register. So the first part is authentication and the second part is registration. So how do we know the IMS user is registered to IMS network? So as soon as we receive, we means the UE receive the 200 OK from the IMS network, which means the IMS registration towards the IMS network is successfully completed. Right. So this is basically, the slides basically talks about the different messages flow, which we already discussed. The UE, which is nothing but terminal send the register message to PCSF, P talks to ICSF, I talks to HSS. Now HSS reply back, ICSF talks to SCSF, SCSF talks to HSS, HSS reply back to SCSF, ACF send back to ICSF, ICSF send back to PCSF, and PCSF send back to the terminal. So this is basically the authentication and the registration call flow. So you have a register message, you have so this is how the first part is authentication and the second part is the register message. So you have a 200 OK, the 200 OK is nothing but the UE register to IMS network, right? So next we are talking about the IMS call flow. So here I'm going to explain two call flow scenarios. One is the user A and the user B are registered to IMS network, which means both are IMS subscriber. And the second call flow scenario is user A registered to IMS network and the user B is a legacy users, which means a PSTN number or a landline number. Yeah. So we have the UE, the A party. So we have the PCSF. Let's say example, the we already saw the IMS authentication. We already saw the registration process. Now we are going to explain the IMS call flow. So the UE, the user endpoint, send a register. I mean here during the call it sends something called SIP invite. So initially we saw the SIP register message, that is for the authentication and the registration process. So once the registration completed, we got the 200 OK from the IMS network towards the UE. So now the UE will send SIP invite message to PCSF. So since the UE is already registered to IMS network, PCSF will have idea about the SCSF information. Now PCSF can directly send the SIP invite message to SCSF, which is nothing but the serving call session control function. Of course, if the register message, if the UE wants to talk to the TAS telephone application server, it has to send the SIP invite message to TAS as well. So let's say the UE, the user endpoint, is an IMS subscriber and he is making a call to a legacy network. So this is our first call flow scenarios. So the SIP invite message received by SCSF, the serving call session control function. So how does the serving call session control function knows the B party is an IMS subscriber or not? So again we have somebody called enum or inum. So as soon as the SCSF receive the SIP invite message from the PCSF, the SCSF send a query to enum saying that I have got a SIP invite message from PCSF. Can you check in your database whether you have the information about the B party? So it's kind of a query sent by SCSF to enum. So as soon as the enum receives this query from SCSF, enum check in his database about the B party. Suppose enum has the details of the B party in his database, which means the B party is an IMS subscriber. When enum check in his database and he is not able to find the information about the B party, which means the B party it's not an IMS subscriber. So basically what it means, the enum or the inum will have the inum or enum has the details about the IMS subscriber details. So SCSF send a query to enum, enum check in database, enum reply back either yes or no. If the answer is yes, which means the B party is an IMS subscriber. If the answer is no, which means the B party it's not an IMS subscriber. So let's say the answer is no. If the answer is no, which means the B party is not an IMS subscriber, right? So enum sent an answer equal to no to the SCSF. Now what SCSF does? SCSF has an interface towards BGCF, breakout gateway control function. We already spoke about the functionality of breakout gateway control function, right? It used to break out the call from an IMS network towards the PSTN network. So if the answer is no from the enum, SCSF send this message to BGCF, breakout gateway control function, in order to break out the call. So the breakout gateway control function send this message to MGCF, which is nothing but media gateway control function. We already spoke about the media gateway control function is the IMS gateway to PSTN and the circuit switch users. So basically when an IMS users want to talk to the PSTN network, the media gateway control function plays a major role. So the BGCF send the breakout gateway control function send the SIP invite to MGCF media gateway control function. Then we have the PSTN network or the legacy network. So we already spoke about ISUP, the ISDN user part. So basically the media gateway control function convert the SIP protocols to the ISUP. So this is how when a user from an IMS network tries to call, okay. So now we are going to discuss about the architecture of IMS. So we already discussed about the different fundamental elements of IP multimedia subsystem. Those are PCSF, ICSF, SCSF, then we have HSS, then we have PCRF, then we have application server. So as you can see here on the architecture, in addition to the PI and SCSF, we have one more element which is called BGCF, which is nothing but the border gateway, or I would say breakout gateway control function. So the BGCF is nothing but the breakout gateway control function. So what is basically the functionality of the breakout gateway control function? The breakout gateway control function basically used to break out the call. From the name it says that it's used to break out the call from an IMS network to a circuit switch network. So the breakout gateway control function is only used in session that are initiated by an IMS terminal and addressed to a user in a circuit switch network. So what it basically means, when an IMS user tries to call to a circuit switch network, which is your legacy network, or to a PSTN, which is nothing but your landline, the breakout gateway control function uses its functionality to break out the call from IMS to the legacy network. If the telephone number belongs to the same network, then this element route the SIP session to a proper circuit switch gateway. On the other hand, if the telephone number belongs to another network, then this element will route the SIP session to another BGCF. So basically what it means, so we discussed about an IMS UE terminating a call to another IMS subscriber. So we saw how the SIP invite sent by AUE to PCSF, how PCSF send this invite to SCSF, and how SCSF find out whether the B party is an IMS subscriber or not. Generally it sent a query to enum. If enum says the answer is yes, it means the B party is an IMS subscriber. If the enum send an answer no, it means the B party it's not an IMS subscriber. So if enum says no, then what SCSF does? SCSF send this invite to breakout gateway control function. The breakout gateway control function break out the call from IMS to the legacy network. We have something called media gateway control function, which convert the SIP protocol to ISUP. We already discussed about that. So let's say now the both of the subscriber, both of the handset or both of the UE are IMS subscribers. both are registered to IMS subscriber. So which means when the SSCSF query to enum, the enum should reply back answer yes. So what basically it does, it check in database if enum find out the subscriber details in his database, enum say yes, then which means the SSCSF send this invite message to the B party ICSF, right? So this is basically the B party ICSF. So as soon as it reaches to ICSF, the ICSF has to find out the SCSF of B party. So we know the ICSF talks to HSS in order to find out the SCSF of B party. So once the SCSF, once the ICSF got the information from the HSS about the serving call session control function, the ICSF forward that message to SCSF. So who is the first point of contact from the UE point of view towards the IMS? Of course, it's a PCSF. So when I say the first point of contact as well as the last point of contact is proxy CSF. So the SCSF forward this message, the SIP signal message or SIP invite message to the proxy CSF. That is the last point of contact from an IMS towards the UE. And as soon as it reaches to PCSF, the PCSF forward this message to the B party or the terminating IMS network. So this is how the call from A party would terminate to B party. So we have discussed about the IMS architecture. We have discussed about the CSF, 3 different types of CSF, PCSF, ICSF, and SCSF. We discussed about HSS. We discussed about the functionality of PCRF. We discussed about BGCF, that is breakout gateway control function. We discussed about application server. Then we went through the authentication process, how a UE authenticate to the IMS network. Once it authenticated, how the UE would register to the IMS network. Once it registered to IMS network, we saw how a UE will terminate the call to B party or how a UE will terminate the call to the legacy network. Yeah, so basically these are the things which we wanted to discuss about IMS today. So if you have any question, you can reach out me. My email ID is maneesh.kp@nokia.com, or you can try to reach your champions. We have champions associated with each universities. You can contact them and they will contact me if you have any doubts. Yeah, thanks for watching my video. Thank you. Bye bye.